benefits of calculators in the teaching and learning of mathematics, to be conducted by Emeritus Assoc.Prof Barry Kissane, whom I'm going to introduce shortly. My name is Dr. Longkot Maidong from the Mathematics Department of IPST. I'm very pleased to be master ceremony for this morning. Before we start, may I ask Mr. Kimura, Takuto, and Mr. Yonehara, Tetsuya, from CASIO Computer Co Limited, to give a welcoming speech to the participants for about 10 minutes.
Sawadee-ka. I'm correct. Bonjour, Kimura from CASIO Japan.
Sawadee-ka. Bonjour, Yonehara. My name is Yonehara. Is it correct? We come from the CASIO Tokyo together, and we are in charge for the CASIO education. It means to support mathematical education more better, especially for the scientific course. Thank you so much for inviting us to make this kind of very good opportunity.
So, Hong Cup for attending this today's program, and the Hong Kong Cup for IPST for hosting us today. Thank you very much. So at the beginning of this program, we briefly introduce our company and our educational activity by using this presentation. Firstly, about CASIO Computer. Our headquarters is Tokyo, Japan, and our company was established in 1957. And our chairman and CEO, Kazuo CASIO, and President COO, Kazuhiro CASIO. And our employees, more than 11,000 people. And this is our CASIO's corporate philosophy. Our philosophy is creativity and contribution. It expresses our strong commitment to contribute to the society by creating original and useful products that only CASIO can. Based on our philosophy, CASIO's product development policy is making something from nothing, namely from 0 to 1. So, based on our company philosophy, let me introduce one important word, gakuhan. This is a CASIO original word. We always use this word to use and share with teachers when we were in each country to collaborate with them to develop the better math education with scientific calculators. So I would appreciate if you remember the word gakuhan today. Gakuhan is the activity to realize better math education by supporting teachers and students. Namely, we would like to achieve students can improve problem-solving skills, and students can learn mathematics deeply and differently. This is the achievement we want to do through the gakuhan activity. So, gakuhan CASIO educational activity for math education is composed of 4 key elements. The first, the product. Second, solutions. And third, academic events. And the fourth, resources. This is important four keywords of CASIO Gakuhan activity. So, Mr. Yonehara, my colleague, will briefly explain about our products.
So for the first, I want to briefly introduce our product. So CASIO have a wide product lineup, which is adjustment for each education, such as primary, university. We have many kind of calculator, working kind of software. Standard scientific calculator, programmable calculator, graphing calculator, graphic calculator with a computer algebra system, and financial calculator, and we are having PC software for the teachers. So today I want to introduce a new product with standard scientific calculator. Our first scientific calculator is established in 1974. This calculator is totally designed for the engineer, not for the student. But now we are changing the mind. We think calculators are not for the only engineer, but for the student. So last year we launched a new model. Model name is Class Series. So this model is designed for the student. So for example, previous models menu is written in the short word and abbreviations. Maybe no one understand this short word menu. So for the new model, we implement the icon display and flowcharts. And for the new models, we can customize the language for each country. This we are showing the Arabic. Arabic. And we implement some new functionality. We know recently mathematical education needs some new features. This means like statistics in math education. Now statistics is a very important subject, coming to the important subject. So we implement a spreadsheet functionality for this calculator. This is totally designed for the current mathematical movement.
Assistant to the President of the PST, Dr. Scott, so she's going to give a opening speech.
Sorry for interrupt your presentation because but we have this morning we start the meeting from 7:30 in another room, and we have another meeting outside, very far away from here, but it's the meeting with the OECD pilot study about the creativity. So that's why I'm interrupt you for a while, and we continue for your presentation later. So Professor Barry Kissane, Mr. Yonehara, and Mr. Kimura, I'm very pleased for coming to IDST as a guest for our organization today, and thank you very much for your support for the workshop today for the teacher from around the country. I think today we have around 12 teachers from many provinces from ฉะเชิงเทราปทุมธานีบุรีรัมย์สกลนครราชบุรีอุดรธานีสุรินทร์นครปฐม and Bangkok. So I hope that your presentation from CASIO and Professor Kissane would be very helpful for the teacher and our staff. We have the IPST staff today in the workshop and very young staff, it's a new generation. Long time ago, more than 15 years ago, I talked to Dr. Kissane. We have the workshop with Dr. Kissane here. Maybe we back to the 15 years ago and the time back again today. So I think around 2000 or 2001, at that time we cooperate with CASIO and Texas Instruments, both company, and we also have the training for the math teacher around the country. At that time, some school have the many calculator, like a class for the calculator, both CASIO and Texas. So many teachers at that time already retired now, but they still be the expert for us to help us if you want to share the experience with the teacher for the next time. That my experience more than 50 years ago. So for today, I thought Dr. Kissane have a presentation to try to convince how to put the technology like ICT or maybe calculator in the curriculum. And this time, IPST working on the revise the old curriculum, not the old, is the present curriculum in 2008, and we propose to announce with the MOE maybe in 2007, 2017 or maybe next semester. It depends on the Minister of Education that we will the meeting this afternoon at the MOE to talk about the when we will announce the new curriculum. And the complaint from the educator in Thailand and also the complaint from the school, they also request how to put the technology or how to put the software program or maybe the calculator or something like that in the curriculum of mathematics, or maybe in the ICT part of the design technology subject or in the ICT subject. And now we as IPST try to introduce the STEM education initiative since 2 years ago, and we try to increase the number of students or the number of the students who want to be the study in the science program, and also we try to cooperate 3 subjects together. I mean the science, the mathematics, and the ICT and DT in the same substance. In our curriculum we have a subject. Maybe we call the subject, not the substance. We have a subject, but if we can combine 3 together in the new name, like the STEM education or the STEM group of the subject, and we can add more the number of hours for the student to learn in each subject. So this is our new expectation for the new curriculum. And also in the new curriculum, we try to integrate the example of the STEM education in the for us in the mathematics, and how you apply the concept in mathematics in the real world problem also. So this is the intention of IPSC for the new curriculum. So we hope that our staff is a young staff, for the new generation and also all teachers who participate in the workshop today can work together and can cooperate how you can bring your knowledge and the skill that you got from Professor Kissane and Mr. Kimura and Mr. Yonehara from CASIO to set this one or to bring this one to your classroom or maybe to the new curriculum that we try to revise and decrease the number of content as the Minister of Education agenda to decrease the content, decrease the indicator in the curriculum. But why it decreased and how we can integrate the ICT in the curriculum. And this is the question for the participant in this room and how to apply what you got from the workshop today and tomorrow to be useful for your student and your school and for IPSC also. So tomorrow we meet again, but today is very busy. They start from 7:30 and maybe not have time to back here. And tomorrow we can, if during the day, if I can go to this room, I will do that. Okay. Thank you so much and hope the presentation today and tomorrow you have a chance, very good chance for Dr. Kissane, who is a very old friend for IPST long time ago, and please feel free to ask questions if you don't understand or maybe if he speaks very fast, but no, I think not very fast, and you can understand what he tried to integrate the ICT in the mathematics instruction. So please feel free to ask the question and share the experience together between the participants in this room. Thank you so much.
Thank you very much, Dr. Assoc.Prof, Assistant to the President of PST. She certainly would love to stay with us, but due to the disease schedule, she needs to take another meeting. Anyway, thanks for the orientation and what we're supposed to do and learn during this 2-day workshop. So may I invite Mr. Kimura and Mr. Yonehara to resume your presentation, please.
So let's continue about the product briefing. So we understand each country have our own curriculum and the demand for the technology is different in each country. So now we have many customized curricula for each country, 14 areas, 52 models. So this means we can adjust Thailand curriculum for the near future if we can work together. So I hope today and tomorrow's meeting will be fruitful and then we can make work together. I hope so. Thank you so much.
Thank you, Mr. Yonehara. So let me continue the presentation. The second important keywords, solutions. We CASIO not only produce only the products, but also we always try to give solutions to the schools and the teachers. For example, the workshop for the teachers and sometimes the pilot schools to evaluate our activities and also support the students by opening math competitions. This kind of solutions we always do in each country all over the world. And the third is the sponsorship to academic events. We always make a sponsorship to an important international academic events like ICME, ATCM, or EARCON, and we always try to introduce our scientific areas at CASIO booth and also conduct workshop by CASIO's corporate teachers, like Mr. Kissane is shown on the right side. And fourth important keywords is resources. We have our own educational website. So if you're interested in, please visit our website. This website is composed of three elements. The first, the product information, and second, educational resources. And third, we make a download service of our software to the teachers and the students. For example, activity books available in our website is so many activities is available, like the books shown on the left side is written by Mr. Kissane with our important scientific calculators, and also we have many corporate teachers in each country to kindly write books with CASIO scientific calculators. So through these activities, namely Gakuhan activities, our hope is to help support an education that enables children to learn how to approach the challenges in their lives with the confidence that they can analyze and solve any problem. Thank you very much for listening to our presentation. Sorry, my Thailand is not so good.
Mr. Kimura and Mr. Yonehara from CASIO Computer Co Limited for your presentation. Your products are very interesting, and especially the new term Takuto we're supposed to experience during the workshop. So thank you very much for your presentation. So this workshop is co-organized by IPST, CASIO Computer Co Limited, and CASIO Marketing Thailand. It's going to be here today and tomorrow. So next, may I introduce this speaker for the workshop, Emeritus Associate Professor Kissane. If I'm supposed to have, please present yourself. If I'm supposed to present all this past work, experience, and achievements, I need the whole morning to do that. So if you don't mind, I'm going to give a very brief version of his work. Emeritus Associate Professor Kissane worked at Murdoch University in Western Australia. He was involved in teaching and research in both primary and secondary mathematics education, as well as some administrative responsibilities. He wrote and co-wrote a number of books related to using calculators in mathematics education for both teachers and students. Though he has already retired from the position, but he continues his passion in this field. And today he's going to share his expertise on the calculator use in mathematics education with us. Regarding the agenda, I suppose you have the schedule of the 3 days in your folder. So we're going to have a presentation in the first session. We're going to have a break at 10:30 to 10:45, and then we resume until 12:15 for lunch. But I think you have a schedule in your hand, so we will follow this schedule. So without further ado, may I give the stage to Emeritus Associate Professor Barry Kissane. การบรรยายจะเป็นภาษาอังกฤษนะครับแต่ว่าถ้าอาจารย์ท่านไหนฟังไม่ทันหรือว่าอยากจะให้ช่วยแปลก็สามารถยกมือได้นะครับ We have bilingual staff scattered around the room, so วันนี้พนักงานสสวทนะครับที่สามารถสื่อสารภาษาอังกฤษได้เขาจะช่วยแปลให้นะครับถ้ามีปัญหาอาจารย์สามารถยกมือได้เลยครับ Thank you very much.
My Thai is very poor, so I will speak in English, but I will try to speak very slowly. Is it necessary for me to use the microphone? Can you hear me at the back without the microphone? Can you hear okay? I would prefer to not use a microphone. I don't like microphones, but if I have to, then I will. It's lovely to be here. Thank you very much for coming. Those of you who have come from the school and members of IPST staff. In fact, it's lovely to be back here. I was here, as you were informed earlier, some years ago, and I'm looking forward to today and tomorrow. I suspect I might have to use this
for a while. Okay. The intention today and tomorrow is to think about this topic, using ICT, but in particular calculators, to improve mathematics learning. And today we have 4 activities. The first of these is for me to make a presentation. I'm going to make some general comments and give a few examples of the use of technology for mathematics. Not too many examples, but a few. And then after the first session, we will have 3 sessions for you to use the calculators yourself with some advice. The first of these will be to get used to using the calculator, because it's a very new calculator and you may need a little bit of help to find your way around. And I'm going to look in the first session at the mathematics of younger students, maybe in the early secondary years, and perhaps even some of the children in the upper primary years, maybe grade 6, grade 7. The second session, we're going to look at some more advanced topics in mathematics and the use of the calculator, and the third session, more advanced topics still. So the first session will be the hardest, because you will be not so much doing things, but listening to a foreign person trying to talk in a way that you can understand. When I was introduced as Emeritus Associate Professor Barry Kissane, that's an awful lot to say. Please, if you would like to talk with me, please just say Barry. I am happy to be called Barry. So, when children learn mathematics, what do they have to help them? What are the resources for learning mathematics? And I think in all countries, my country included, the first resource is the teacher. Nothing is more important than a teacher to a student learning mathematics. That's why I'm so pleased that we have some teachers here today. I am a mathematics teacher. I'm not, I don't work for the CASIO marketing division and the R&D division. I'm a mathematics teacher. And I've been a mathematics teacher for as long as I can remember. I started teaching in 1971, so you can see already that I am extremely old, but I enjoy teaching mathematics, and I know that teachers are very important resources. Textbooks are very important materials. Most students use a textbook or some other written material, and IPST, I know, has responsibility for materials. So we will talk a little bit about that, mostly tomorrow. Tasks. What do students actually do in their classroom? For many students, what they do, too many students, is listen and watch what the teacher does and try and do the same. That's a very poor strategy for learning mathematics, but a very common one. But I would like to, over the next 2 days, think about better things to do than watching someone and copying. And finally, technologies are an important part of the resources for learning. There's been a lot of talk about technology recently, and we have only been in Thailand for less than 1 day. We arrived yesterday. And as you drive around, everywhere there are signs advertising the latest smartphone, the laptops, Wi-Fi, and everyone walking around has something in their ear or their little screen, like this one they're looking at. So technology is all around, and people are asking in many countries, can we use technology in education? So that's an important resource as well. There's another one that I couldn't think how to start with the letter T, so I forgot to finish. The other resource that students find very useful is, of course, other students. Talking with other students, T for talking, there we go. Talking with other students, working with other students, working together is a very powerful resource also. So we will do some of that today, but not so much in this session. The National Council of Teachers of Mathematics in the US has talked about, for some time now, its technology principle. This is a large professional organisation in the United States, of which I've been a member for 40 years or so. And they said technology is essential in teaching and learning mathematics. That's a very strong statement, essential. It influences the mathematics that is taught, and it influences or enhances students' learning. I don't know if that's true in Thailand yet, but I hope to find out in the next couple of days. Essential. Does it influence the mathematics in the curriculum? Does it influence how it is taught? Does it influence how students learn? It can, and indeed it should. But which technologies? There are so many. I'm talking about students using technology, not just watching the teacher use technology. Computers, computer software. In Australia, many students have computers. Many classrooms have laptop computers. I recently did a large study where I asked teachers what software they used. Mostly they didn't use any. There was a little bit of free software, GeoGebra or something like that, but mostly they didn't buy any software. It was too expensive, and it wasn't very good. So the computers look good, but many teachers, indeed teaching in classrooms where there was a computer, didn't use it much. The students didn't use it much. The internet, potentially very useful. On my website, I've got many links to websites, many of which are very useful. But what do students do? There's a lot of concern internationally that when you put students in touch with the internet, what do they do with it? Facebook, they message their friends, they write to their friends. Adolescent students spend a lot of time on the internet. Rarely do they use it well. Sometimes they might, mostly they don't. Tablets, wonderful devices, but terrible for mathematics. There are very few good software devices for tablets. There are some, but there are very few. What do students do with their tablets? Facebook, messaging, browsing, just being distracted. I've spoken to many teachers who said, every student in my class has a tablet, but when we do mathematics, I tell them to put it away because I don't know what they're doing, and they're almost certainly not doing mathematics. Smartphones. Yes, you can do some mathematics on a smartphone. Not much. It's usually quite poor, but you can. Calculators. That's what we're here today for. And there are many technologies. I want you to know that I know about all of these. I own a tablet. I own an iPad. I have an iPod. I have several computers. Too many computers. I know about all of these things. I've used lots of software. But I'm here talking about calculators. Why is that? Because I'm a teacher. And I want children to learn mathematics, not to be distracted and do all of the other things they often do with technology. Some people in some countries, and I don't know about Thailand, but some people are concerned if students have a calculator, they won't really learn mathematics. And lots of people have done research about that. This is a long summary and too many words for you, I understand. But it's a summary of lots of research. What does it say? It says we should stop asking the same question. The question people keep asking is, will having a calculator be damaging for students to learn mathematics? The answer is no. All of the research reaches the same conclusion. And these people said we should stop asking the same question to which we already know the answer, and instead should look to see how can we use the technology to help students learn mathematics, because we can. So that's why we're here. Scientific calculators. Since I started teaching, they have come a very long way. Mr. Yonehara mentioned that the original calculator from CASIO, more than 40 years ago, was for engineers and for scientists. That's why we call them scientific calculators. I don't like that name. I don't like the impression that these are just for scientists and engineers. The calculator has been designed for education since then. Deliberately designed. The changes on the display, you see here an integral and a fraction. That's because we want it to show mathematics as we write it. The changes in functionality. What do we want the calculator to do? The things that calculators do are the things that teachers say they would like to do, like their students to do with a calculator. And user-friendly. It should be easy to use the calculator. You should not have to use the manual. I will get you started today, and hopefully you will then find it easy to use the calculator. All of the changes, all of them, for calculators in the last 40 years have been for education. And most of them have come about because of conversations between people like myself and yourself and people like this. Scientists and engineers don't care about fractions. They don't need them on their calculator, but children do. Here's an example. All of that other technology, the computers, the iPads, the iPods, the internet, the smartphones, they were not designed for education. People try and put them into education. That wasn't why they were designed. A calculator like this was designed for education. It's very different. Similarly, graphics calculators. The first graphics calculator I ever used was in 1986 in Chicago, where I was working at the time. Was a graphics calculator, and they have become very important internationally for mathematics education. In Australia, except for one state, essentially all students use a graphics calculator in their senior secondary years, in year 11 and year 12, many of them with a computer algebra system. So this is arguably the first technology that was specifically designed for education. And when I came to IPST all those years ago, it was to talk about graphics calculators and to work with graphics calculators. But today we're going to look at scientific calculators mostly. Tomorrow I will give a brief demonstration about graphics calculators too. So, calculators. Mathematics is not calculation. We know that. We're mathematics teachers. Mathematics is about thinking, not about getting numerical answers. But lots of people out there think that mathematics is about calculation. And in fact, some people don't want to use calculators in schools because they think if you use a calculator, you won't be doing mathematics. The calculator will do the mathematics. It's a common impression. When we speak even to our taxi driver the other day, he said, oh, no, you can't use a calculator in school. The implication was the students won't learn their mathematics then. We know that's not true. And you'll see today many examples of that thinking being defective. So I want to share with you my opinion. The purpose of a calculator is to help create meanings for objects, to make sense of things. I spent many years teaching mathematics teachers, and I used to say to them, your job is to help students realise that mathematics makes sense, that you can understand it, that it's a sensible activity, it's not arbitrary. It's not just doing what the teacher said because that's what the teacher said. And other technologies, yes, they're very powerful. My computer's very powerful. Smartphones are very powerful. But I'm interested in a calculator or in a bit of technology that is available to all students at all times, and affordable, and educational. In Australia, students routinely use their calculators everywhere. At home, homework, in school, doing assignments, in assessment, in the equivalent of national examinations, everywhere. You can't do that with a laptop or a tablet because not everyone can afford that. I'm interested in technology being integrated, not just an optional extra for some students in some schools with some interested teachers. I'm interested in a technology for everybody. That's why I'm here. So a technology for learning mathematics. Handheld, portable, fits in a pocket. I can prove that. It's in my pocket. It's small enough to put in a pocket. We used to call them pocket calculators. Doesn't need Wi-Fi. Doesn't need extra software or apps. Doesn't need maintenance. Doesn't need staff. Doesn't need an IT department or a system upgrade. You turn it on and it works. Simple. I'm a teacher. I like things that do that. I don't want to turn it on and then fix it, or turn it on and nothing happens. I want to turn it on and it works. Affordable. most technologies that you see around the streets of Bangkok on the big signs are not affordable to many families and many children. So they're not in the curriculum because not everybody can have them. I'm interested in a technology for teaching and learning and assessment. All of them, not just some of them. Some technologies used in schools are just used by the teacher. That's not very powerful. And I'm going to show you some examples, but I want to give you some background first. Myself and my partner Marion Kemp, some years ago, wrote a model with thought, how can we describe how calculators are useful for education? And we decided there are 4 aspects. Representation, to represent, show mathematical ideas and their relationships. And I'll show you some examples. We want children to learn about concepts, learn about mathematical ideas. What ideas? Fractions, decimals, integration, convergence, limit, lots of different ideas. We want to show these ideas. Function. Computation. Yes, some computation is important, particularly when you have messy numbers, real numbers. If we gave students the task, find the volume of this room, how much air do each people have? The numbers are never convenient. They're not whole numbers. You need to work with some kind of technology to do those calculations. If you don't use technology in the curriculum, you never deal with real problems. Dr. Sapatra talked about real-life mathematics. You can't deal with real-life mathematics if you rely on doing your computation by hand. You can only deal with pretend real-life mathematics. Exploration, playing with ideas, investigating, exploring. You will see some examples today and you will do some. And finally, affirmation. That's probably a strange word. When students use a calculator, we want them to think, what will happen? Is that what I expected? How do I understand what is there? Is it not what I expected? Am I surprised? What's happening? What's going on? That's what the emotions and the experience of using a calculator is for. This model is described on my website, and you can, if you write down that web page, or if you go to my web, I'll give you my web page at some stage. You can go to my website if you want to read the details. So now let me
So the first thing I would like you to think about is that the calculator, I like to think of a calculator as a number line. All of the numbers we're interested in, fractions, decimals, whole numbers, percentages, powers, roots, logarithms, are all there. And the calculator is responsive. When you do something, it responds. For example, on my calculator, if I put in the fraction 7, putting a decimal, 0.7, into the calculator, and I'm pretending I am a student. I put in 0.7, press equals, and the calculator responds, comes back, and it says, oh, it says 7/10. How strange. I said 0.7, the calculator said 7/10. And if I do other things on the calculator, like that, I can restore 0.7. And if I put in something different, some students think 0.700 is a bigger number. 0.700, much bigger number than 0.7. Yeah? Oh no, it's the same. It's the same number. How strange. They expected to get something different, and they didn't. And some students will think that, for example, 4/10 is a fraction. And if we look at the fraction 4/10, oh, it's 2/5. It's a different number. But I expected it to be 4/10. But indeed, it is still 0.4. And indeed, some numbers like 37 cents is 37 hundredths. So the calculator knows about all of these numbers. It knows that a fraction is one number. It has one place on the number line. And 37 hundredths is 0.37. So you can see this is my number line. We will spend lots more time doing that, so I won't spend time making that point further now. So young students, can you hear me okay when I talk like this? Is it okay? Is it okay, or would you rather I use the microphone? Which one? Put your hand up if you're happy with me to not use the microphone.
อาจารย์โอเคไหมครับถ้าเกิดไม่ใช้ไมโครโฟนหรือว่าอยากให้ใช้อ๋อ
But be worried that your voice won't be recorded. Okay.
So I will keep using the microphone even though I don't like it. Okay, so representation. The first idea. We represent ideas. Fractions, decimals, percentages, relationships between these. The calculator can help students see what is happening, and indeed, I'll sit down because it's easier here, if you don't mind. We represent, we represent, we present again. For instance, 9 divided by 2 is 9 divided by 2. Students need to learn that, in fact. That's what 9 over 2 means. 9 divided by 2. Some students don't like having a fraction with the number at the top bigger than the number at the bottom. So on the calculator you're able to flip from one to the other. And you can always flip to a decimal or go back to a fraction. I want students to move in those kinds of ways, to represent things in those kinds of ways. Some representations are problematic. 2/13. If it's a decimal, it's a problematic decimal because it's a recurring decimal, but it doesn't show an infinite number of digits. And if we go back the same way, 0.24242424, thinking of a recurring decimal, nothing happens. It's not a fraction. But if we get a bit further, 24242424, have more digits, you can see the calculator recognizes that this is a recurring decimal. It's the decimal 8/33, the fraction 8/33. or if you like, 24 over 99. And that's the decimal. So the representation can flip from one to the other. We will see many more examples of representation later, but I'm conscious of time now. There's a big change here. Oops. Sometimes calculators are used to do the computation after we've finished the mathematics, just to get the answer. And in many textbooks, that's what seems to be the case. The calculator is used at the end. A big change is to say the calculator might be used at the start, before students have learned the mathematical ideas, not at the end. It's part of learning. It's not just something to use after the learning has taken place. That's a big change of perspective. Computation. Many computations should be done mentally. In my elevator this morning, I noticed that in the hotel we're staying in, it says there's 1,350 kilograms altogether. And how many is it? I think it's 18 people. 18 people permitted in the elevator. So I looked in the elevator and thought, they are very big people. 1,350 divided by 18. I think students should do things like that in their head. It's a large number. I'm sure that you can do things like that in your head. Was it? I thought it was 8, it was 17. 17. And it turns out that that number is 79 kilos every person. Wow. In Thailand they have very large people. But many computations need to be done with technology. So students spend their time thinking, not calculating. Let me give you a small example. I looked on the internet to see the population of Thailand, and I know there is a national statistics office in Thailand, and the population in the year 2000 was, as you can see, 60,606,947, and the growth rate was 1.05%, a slow growth rate at that time. So what population would we expect in 2016? Students can't do that in their head. It's too hard. We can do it on the calculator or some other device. Calculator's the convenient one. 6947. I'm going to store that number temporarily in memory number A because it takes too long to type it in. So just to reassure you, here's the number. That's the population in the year 2000. So in the following year, it should be 1.0105 times as large, 1.05%. So in 2001, 2002, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the population this year should be about 71 million. That's a computation that makes sense for someone in Thailand, but without a calculator you can't do that. Is that the population now? Do you know? Does anybody know? Fortunately, I know. The population in Thailand now is about 68 million. It's not the same as we got up here. which was, just have to go back one step, not 71 million, 68 million. Not the same. But I want students to learn that mathematics, mathematical modelling is not exact. It's close, but it's not the same. And that's part of learning about using mathematics in the real world. These are models. And the model says, the model I'm using is every year the growth rate is the same. But it mightn't be. And indeed it isn't in Thailand. In PISA, people talk about mathematical literacy, about using mathematics in the world, thinking about the mathematics in the world. You can't do that without some technology. And if you have a curriculum where students are not using technology often, they won't do that. It will be pretend mathematics. And PISA has also accepted that mathematics is much more than simply formal mathematics, but thinking about using mathematical ideas elsewhere. Okay. I want to move on to exploration briefly, just to describe another aspect of the use of the technology. Remember, representation, computation, exploration. We've already done this. What is the population growth rate? If the population is 60 million in, that is this figure over here, in the year 2000. Go back to here. What will it be in 2040? Well, that will take a long time, much too long. And so in mathematics, we have powerful ways of thinking about doing something over and over and over again. We would simply do this. We'd say multiplied by 1.0105 to the power 40. That's where students learn about powers. And the result, oh, very large number. 2040. 92 million people, according to this model. What about, when will Thailand have 80 million people? How would we know? Well, it would be less than 40 years. So I'll just edit this a bit. Maybe it's about 30 years. No, it's less than that. I'll edit it again. Maybe it's about 25 years. No, it's more than that. I'll edit it again. Maybe about 28 years. No? Maybe 27. So according to this model, it will take until about the year 2027 for there to be 80 million people in Thailand. But there are other ways of answering this question on a calculator. Other ways of exploring. For example, on this calculator, we can make a table of values and say, once we understand, 5 to the power x. And we can tabulate some values, say from 0 to, say, 29. Steps of 1. So here's a table. There's the first year. Here are these other years. And we can see that in around about, after 27 years, it's about 80 million. It's a different way of thinking about the problem. Or on this calculator, we can think about this as an equation. Here's the equation. A times 1.0105 to the power x is equal to, say, 80 million. 8 by 10 to the power 7. When does that happen? that's not right. We do that again. Let's go back to here. Oops, I'll need to start again. Beg your pardon, I got myself confused. I've changed that number. Oops. The number should be, I'll put it in properly, 606,947 multiplied by 1.0105 to the power x. When is that equal to 3, 8 by 10 to the power 7. So we can solve an equation. And it looks like about close to 27 years. The point I'm making is we can think about the same problem in several different ways using the calculator. We could also think about this as a statistical application. So you could think about modelling in statistics. Think about the population, look at the actual data and see how that has changed. Over here you see the population of Thailand over time. There's a possibility on the calculator to do statistical models. We could say in 1909, and I'm just going to put some quick values in here, 1960, say, and the year 2000. I'm being quick because I want to, I don't have time to do it properly. We'll do it properly later. And in that first year back in 1909, the population of Thailand was only 8 million. 149,487. Very small country in 1909. In 1960, 26 million. 257,916. And in the year 2000, as we saw, 60 million. 606,947. That's only 3 data points. I know that's problematic, but I just want to make the general idea. You cannot do statistics without technology. Well, you can, but it is very, very unwise. Students will never deal with real data if they're not using technology. They will never deal with their own data if they are not using technology. On this calculator, once we've put those data in, we can get some information. You can see the correlation is very good, the linear model is quite strong, and we could use that model to predict in various ways. So we could, for example, say, what will the population be in 2016? So in 2016, we're going to do a regression calculation, and we're going to say what would the value for the population be in 2016? 65 million. Not very close, but not too bad. We have used only 3 data points. We can clearly do a lot better than that. So the exploration might be statistical, not just other kinds of mathematics. Often with a calculator, we can explore problems in several different ways. So we could ask questions like, what would happen to Thailand if the population growth rate reduced from 1% to 0.8%? Or what growth rate would we need to limit the population to a certain size? We can ask real questions about real world. And what mathematics do you use when you do that? Percentages, sequences, functions, equations, exponential growth, mathematical modelling, approximation, rate. All of these mathematical ideas are involved. And this is a rich opportunity for students to talk about those ideas and to learn about them, not just to do calculations. And it's not just for arithmetic. A modern calculator can deal with many more sophisticated mathematical computations. So, for example, the computation of finding the derivative. Finding a derivative function. For those of you who are teaching in the senior secondary school, the derivative of x squared when x is equal to 1 is 2. And the derivative of x squared when x is equal to 2 is 4. And the derivative of x squared when x is equal to 3 is 6. And if we go back and look at those, we can see a pattern. When x is 1, the derivative is 2. When x is 2, the derivative is 4. When x is 3, the derivative is 6. The idea of a derivative function is the one that describes that pattern. And we could say, what would be next? What would we think the derivative would be when x was equal to 4? It looks like it would be 8. And indeed it is. And we can predict if x was 5, it should be 10. And it is. Because mathematics makes sense. It's predictable. It's understandable. And the calculator is showing that. Other computations, again, not just for arithmetic, integration. The integration, the area under a curve. Now, I know people in primary school don't care about this, but people in secondary school do. Area under a curve, say between 0 and 1, is 1/3. It's a numerical integral. And indeed, if we had a different one, if that was not 1, but 2, it's 8/3. Or if we had a different function, like x squared, add 1, the area, the curve is shifted up, the area is larger, it's larger by 1, so it's 1 1/3. Why is that? It was originally 1/3, now it's 1 more underneath. So the calculator can do things that allow students to think about what's happening here. Summation with series. I know in Thailand you study sequences and series. The very famous problem of the boy Gauss adding the first 100 integers, 1 to 100. Notice the calculator represents this in the same way that we represent it in the textbook and on the blackboard. And the result, of course, is the same one that the boy Gauss got. What the boy Gauss couldn't do, well, I'm sure he could do, but didn't do quite so quickly, is to say, what if this was the squares of those numbers? Of course, on the calculator you can represent that and obtain it relatively easily. Matrices, complex numbers, all of the things that are more sophisticated in secondary school are also handled by a calculator designed for school. The square root of 20 is 2 root 5. That's not a problem. But the square root of negative 20 gives an error. because you cannot find the square root of a negative number if you stick with real numbers. But if we change to the complex mode, now if I find the square root of negative 20, the calculator has no problem because it's using the complex numbers. And other operations with complex numbers, like 2 add 5i squared, is just a computation. So the computation might not just be arithmetic. And similarly, some computation involves matrices. We can define a matrix, 2 rows and 2 columns, like this, 2, 3, negative 7, 5. So we have a matrix. Now if we'd like to get the inverse of that, here's the matrix. It's represented on the screen. We represent it in the same way we normally represent it. If we'd like to say find the inverse of that matrix, the inverse of a matrix is a tedious thing to calculate. It's not insightful, it's just a nuisance. But we can see here the calculator has shown us both the fractions down here and the decimals up there. So we can do computation that's more sophisticated than arithmetic. Affirmation. When students put something into their calculator, I always encourage them, and as teachers we want them to think about what's happening, to think about what they expect, to think about what it means, to make a guess, to predict, to think, in other words, not just to press buttons. You won't find in any of the material that I've written lots of buttons to press. When I look in materials for calculators and there's a whole string of buttons, I get very worried because students spend all their time pressing buttons and not thinking. It's usually necessary to do that because either the person writing the material doesn't understand the calculator or the calculator is very complicated. Not just pressing buttons. But I'll show you a small example. If we have 2 to the power 5 and multiply it by 2 to the power 3, some students think that will be 2 to the power 15 because they multiply the 5 by the 3. And the calculator just gives a numerical result. But we can see the factors of that result, and it's 2 to the power 8. And students can think, oh, why is that? What has happened here? Why is it 2 to the power 8 and not 2 to the power 15? Very strange. So students can be contradicted in their thinking. And when you have an opportunity to be contradicted or surprised, then you have an opportunity to learn. Students can learn by making predictions that are incorrect, and the calculator can reveal what's incorrect about them. They might also find, if they do something like 6 to the power 3 multiplied by 6 to the power 5, they might think, even if they think that's not going to be 6 to the power 15 but 6 to the power 8, when they find the factors, it's not 6 to the power of 8. It's 2 to the power of 8 multiplied by 3 to the power of 8. So again, thinking what will happen and then being surprised is very powerful. We'll see more examples of that over the course of the day. So, learning with calculators in Thailand. There's a very strong case for Thai teachers to take advantage of what the technology offers. And I hope by the end of tomorrow, you will understand why I think that. There's a strong case in many countries. A paper that we wrote, and again you can find it from my website, Marion and I wrote a few years ago, looking at calculators in mathematics education in developing countries. We were in Cambodia at the time, but we were thinking about Cambodia, Vietnam, Thailand, Indonesia, Philippines, many countries around this region, where there are significant economic issues. Significant issues, at least for some students. I know that in Thailand, there are many wealthy people. There are schools with many good resources. There are even schools where students have a laptop and a tablet and a computer at home. But there are many, many other schools where that's not true, where students and their families have limited resources. So my interest generally is in what kind of technology is available to students in a country where resources for some families are quite limited. And I think the technology that's most appropriate is the technology of the calculator. There are more sophisticated calculators. The graphics calculator we will look at briefly tomorrow is much more sophisticated. A computer algebra calculator is much more sophisticated. So we are not working today with this technology because we don't have more powerful ones. We do. CASIO does, and in Australia these are widely used. Graphic calculators is the standard item of equipment for most students in senior secondary school. And for about half of those, a CAS calculator is commonly used. So we know about those. Today our focus, these 2 days, our focus is on the less sophisticated technology. So it's not just the technology. Technology by itself won't have much effect. The tablet by itself won't fix education, nor will the smartphone, nor indeed will the internet or the laptop, nor the calculator. It's the technology together with teachers. And it's very important to understand, as I know most people here do, understand how important is the teacher. The reason I'm spending in theory I retired a couple of years ago, but the reason I'm interested in this is that I am a mathematics teacher and I want to help other teachers. And I know that what teachers do and think is more important than anything else. That's one of the reasons that, and CASIO understands that also, one of the reasons for spending some time developing resources for teachers. The particular publication here is a resource that's quite a large book. I can show you a little bit of it, I think, on here. This one. There's some copies around the room. You might get a chance to have a look at them. You can see it deals with, let's see if I can enlarge that a bit. You can see here dealing with what has a calculator got to do with mathematics? Numbers, functions, equations, trigonometry, exponential functions, matrices, vectors, statistics. probability, modeling, spreadsheets, recursion, sequences, series, calculus. That's what we teach in school, in all countries. So this resource is about providing help for teachers about how does the calculator connect with all of that. And we'll look at some of that material later today. Similarly, it's not just having a calculator and teaching in the same way we always have. Some of the material, of course, in the activity book I just referred to, deals with thinking about mathematics in different ways. And another publication recently made is this one about investigations. Again, you'll see some examples of this a bit later today. In fact, it's only just appeared on the web a few days ago. And there's some notes for teachers, because that makes sense of things. And there are some investigations. Hours, functions, trigonometry, and so on. Things that students can do. But a different kind of thinking about learning mathematics. A lot of the work that we do in the CASIO team, and myself and other people like me, recognises that teachers go through a series of phases. And we will talk about this a little bit tomorrow. I like to think of them in this way. The first phase is, where's the on button? It's the, how do I make this device work? Because a teacher wants to know, how can I find the factors of a number? How can I make a table? How can I solve an equation? How can I invert a matrix? You need to know how to do that. There are things to learn. So where's the on button is the first step. After our first session today, we will spend a bit of time together doing that, finding our way around the calculator and learning how to use it. I know many teachers in many countries. Teachers will not use a technology they are not comfortable with. They are human beings. You're a human being. I'm the same. I'm not going to use a technology that is unpredictable and I will look foolish and I don't know what to do because I will be embarrassed and worried. So where's the on button is very important. The second phase is what we call black line masters. Somebody has produced an activity that you can photocopy and give to students and say, do this. And there's some assurance that it's worth doing, that it's a good idea, that there's something to learn, there's some mathematics to learn. And many teachers, understandably, like materials like that they can give to their students and it's going to be okay. So we'll talk about that a little bit too. And you'll see some examples. I'm showing you some examples from the investigation material as an illustration. Most importantly though is what we call independent use. That is, the teacher is about to teach a topic. I'm going to teach functions, quadratic functions, to my students in 9th grade or 10th grade. And I have a calculator. What will we do? What will we do that's different? We might do the things we've always done before, but we might instead, or as well, take advantage of some new things. And as the teacher, I will think about that. I will think about what suits my students at this moment, because I know what we did yesterday and last week, and I know what we are struggling with, and I know what will help. So independent use is very important, and the materials we have produced have been designed to help teachers begin to develop their own independence. And then the fourth step is what we call curriculum change. That in fact, there are many things in the curriculum that you wonder why they are there. You wonder why we spend so much time doing them, because they have always been there. And there are many things that are not in the curriculum, and people say there's no space for them. So curricular change. I don't need to tell people at IPST that curricular change. But they should change to accommodate technology. They will not change at all unless the technology is available to almost everyone. As a teacher in Australia, I became interested in technology in the 1970s. And people talked about using computers and all kinds of fancy things for a long time. The curriculum did not change for 20 years. It only began to change when we had a technology that everybody had access to. Was that a computer? No, it wasn't. It was a calculator. And it still is. You can't change the curriculum unless you have reasonable reassurance that everyone has access to the technology. So we will talk about that a little bit more tomorrow. And I'll be very interested to know your perspectives from the Thai point of view, both teachers and also IPST staff. So just to refresh, the model for calculator use that is in my head and I'm sharing with you, hopefully you will see some examples of what this means over the next 2 days. Representing ideas, mathematical ideas, on a calculator in various ways. We represent the idea of a function, represent the idea of divergence, convergence, integration, represent fractions and decimals, represent irrational numbers and rational numbers. Computation, many kinds of computation, but mostly computation with inconvenient numbers. Because students who use a calculator well don't just mostly use it for arithmetic. Exploration, you will see many examples and hopefully think of many more where the calculator will be allow students to explore ideas for themselves and investigate things, to learn things. And also this idea of affirmation, checking, hypothesizing, predicting. What do I think will happen? What do I think the result will be? About how large should the result be? And so on. Very powerful. There may be something else, and I would really like people to respond and say there's another thing you're not thinking of here. I'd be interested in that. So we live in a rapidly changing world. I first came to Bangkok almost 20 years ago. It's changed a lot. Some things haven't changed quite so much. The traffic is still interesting, but it has improved. The Skyway has made a big change. There are many new buildings. There's technology everywhere. Every person on the street has a device, and every young person has things coming out of their ears, listening to something on the device. So it's a rapidly changing world. How do we adjust to that? One of my favourite quotations was an educator from the USA called Lin Wan. I haven't met him, but I would like to. And he says, it is unreasonable to expect professional people to change more than 10% per year. It is not reasonable. We are not able to do that. Most of you are young. I am relatively old. I have trouble changing a lot. 10% seems about as much as I can cope with. But he also said, and this is very powerful, it's unprofessional to change less than 10%. To stay the same in a rapidly changing world is unprofessional. To keep thinking about things in the same way. To keep teaching, factorization, for example. Why do we teach factorization? Because we always have. But why do we? What's the really good reason? Is it worth the time it takes and the heartache it produces? Does it produce enough mathematical benefit? I would suggest it probably doesn't, but we could have an argument about that. So, making reasonable changes is important. I'm here because I'm a teacher interested in change, and I think we can make reasonable changes to the curriculum with technology if we have the right technology. Thank you very much. I hope that says thank you very much. Thank you. I have deliberately finished a few minutes early so that there's an opportunity for people to ask questions. I'm happy to try and answer some questions, and of course we will deal with many issues in the next 2 days. But I'll pause here and would you like to borrow mine?
อาจารย์มีคำถามอะไรไหมครับในช่วงเช้าอาจารย์มีคำถามไหมครับในช่วงเช้าจะเป็นการบรรยายภาพรวมในการใช้เครื่องคิดเลขเฉยๆครับแต่ผมสรุปคร่าวๆให้อาจารย์ก่อนเบรกนิดนึงนะครับแต่อาจารย์ท่านใดก็เข้าใจเราก็ฟังอีกครั้งหนึ่งได้ครับเริ่มต้นนะครับมิสเตอร์แบร์รี่นะครับก็แนะนำเกี่ยวกับภาพรวมของวันที่1นะครับวันที่1จะเป็นการใช้ calculator ที่เป็น scientific calculator ที่อาจารย์มีอยู่ตอนนี้นะครับคือรุ่น CASIO นะครับแล้วก็ช่วงเช้านะครับเบรกแรกเนี่ยก็จะเป็นการบรรยายเกี่ยวกับเทคโนโลยีที่มีผลต่อคณิตศาสตร์ศึกษาทั่วไปนะครับแล้วก็อีก3เซสชั่นจะเป็นเรื่องของตัวอย่างที่ใช้กับเครื่อง calculator นะครับอาจารย์ก็จะได้ลงมือปฏิบัตินะครับอีก3เซสชั่นของวันนี้นะครับเครื่องนี้แล้วก็พรุ่งนี้จะเป็นการใช้ graphics calculator นะครับจะเป็นอีกรุ่นหนึ่งที่มีความซับซ้อนกว่านะครับแล้วก็ตัวอย่างก็จะมีเพิ่มมากขึ้นครับเริ่มต้นนะครับอาจารย์เขาก็แนะนำให้รู้จักว่าแหล่งเรียนรู้สำหรับการเรียนรู้ของนักเรียนมีอะไรบ้างเขายกตัวอย่าง4ที่ว่าใช่ไหมครับก็มี teacher นะครับมีคุณครูมีอะไรครับ textbook นะครับ text material มี task แล้วก็มีเทคโนโลยีแล้วก็นำเสนอว่าเทคโนโลยีเนี่ยมันมีความสำคัญยังไงนะครับเหมือนที่ NCTM ก็คือสมาคมคณิตศาสตร์ครูของอเมริกานะครับ National Council of Teachers of Mathematics นะครับได้ให้ความสำคัญว่าเป็นหนึ่งใน principle ของการจัดการเรียนรู้คณิตศาสตร์ในเรื่องของเทคโนโลยีเพราะว่ามันมีความสำคัญไงที่เขาเน้นย้ำคำว่า essential ก็คือว่ามันสำคัญแล้วก็ขาดไม่ได้นะครับ essential ก็ได้ถามว่าเทคโนโลยีมีความสำคัญยังไงปัญหาต่อมาก็คือว่าแล้วเทคโนโลยีตัวไหนล่ะที่เราจะเอามาใช้ซึ่งมันมีหลากหลายมากอาจารย์ก็พยายามจะเสนอให้เห็นว่า calculator เนี่ยเป็นตัวหนึ่งที่มีความเหมาะสมเมื่อเปรียบเทียบกับตัวอื่นแล้วนะครับสามารถที่จะพกพาได้นะครับนี่คือเป็นตัวอย่างหนึ่งแล้วก็การวิจัยก็ซัพพอร์ตว่าการใช้เทคโนโลยีเข้ามามีส่วนร่วมในการเรียนรู้เนี่ยก็จะส่งผลให้เด็กเนี่ยนะครับมีวิธีการเรียนรู้ที่ดีขึ้นนะครับนี่เป็นตัวอย่างแล้วก็นำเสนอเกี่ยวกับพัฒนาการใช้เครื่องคิดเลขตั้งแต่เริ่มต้นที่มีความเหมาะสมกับนักวิทยาศาสตร์เอนจิเนียร์เป็นส่วนใหญ่แต่ว่ามีการพัฒนาให้มากขึ้นให้เหมาะสมกับการใช้ทางด้านการศึกษามากขึ้นนะครับเป็นประเด็นนี้แล้วก็อาจารย์ก็เล่าให้ฟังว่ามันจะมีเปเปอร์หนึ่งที่อาจารย์เขียนว่าแล้ววิธีในการใช้ calculator เนี่ยมันมีบทบาทยังไงบ้างนะครับคือโมเดลในการใช้นะครับหนึ่งก็คือเรื่องของ representation ใช่ไหมครับก็คือคำว่า representation ก็คือว่าเราใช้สิ่งหนึ่งแสดงแทนอีกสิ่งหนึ่งได้อย่างไรนะครับ representation อาจารย์ก็ยกตัวอย่าง support ว่าเช่นคอนเซ็ปต์ในเรื่องของ fraction เศษส่วน decimal นะครับมันแทนกันได้ยังไงนะครับนั้นเป็นตัวอย่างหนึ่งที่ทำให้เห็นว่า calculator ตัวนี้ทำหน้าที่เหมือน real number line นะครับให้เป็นว่า1จุดแทน แทนค่าที่แตกต่างกัน representation แต่ว่าแทนความหมายด้วยหนึ่งสิ่งนะครับด้วยสิ่งเดียวกันครับแล้วก็เป็นตัวอย่างอื่นๆที่เป็นcomputation ว่าcalculator ตัวนี้เนี่ยช่วยในเรื่องของการคิดคำนวณที่แตกต่างไปจากกรณีที่เราไม่มีเครื่องคิดเลขนะครับแล้วก็เรื่องการสำรวจข้อมูลต่างๆที่ทำให้เราสามารถสำรวจข้อมูลจริงได้นะครับแล้วก็สามารถที่จะ predict เหตุการณ์ต่างๆได้นะครับพบกระบวนการที่หลากหลายในการเรียนรู้ทางคณิตศาสตร์ของเด็กนะครับที่ภาพรวมของตอนเช้านะครับหลังจากเบรกแรกก็จะเป็นการนำเสนอตัวอย่างกิจกรรมให้อาจารย์ได้รู้ว่ามีกิจกรรมตัวอย่างเป็นยังไงบ้างหลังเบรกแรกเนี่ยก็จะเป็นตัวอย่างที่เบสิกแล้วก็จะเป็นตัวอย่างที่ advanced ขึ้นตามคอนเซ็ปต์นะครับก็ประมาณนี้อาจารย์มีคำถามอะไรเพิ่มเติมไหมครับตอนเช้าจะยังไม่ได้เป็นการลงมือปฏิบัตินะครับถ้าไม่มีคำถามอาจารย์เชิญเบรกได้ Questions at this point, so it's time for break. Let's have a 15 minutes break and then we come back to this. Thank you.
And when we come back, you'll be using the calculator, not listening to me. So it'll be hopefully more interesting.
Thank you so much.